How's that?
I saw this one guy where he did it like that and it with his wrist and he did it so weird. And then Mr. Sexy went like this. Yeah, Mr. Sexy went like that.
Did he ever draw the circle?
Yeah.
Alright, I don't know why that's not really coming in today. So, here we go. We're going to put a point as close to the middle as you possibly can. So, what do we call this? The blank of the circle.
Hi.
The center, right? So this is the center of the circle. And the center of the circle is going to be named by a capital letter. So remember, well, I don't know if it was so much in your class, but the other day when we did this same test in pre-algebra and we had like y equals mx plus b, when they wrote out, or when some of the people in that class wrote out y equals mx plus b, they used a capital B in that formula, and I counted it half wrong. Because from here on out, you got to be really, really cognizant of if it's a capital letter or if it's a lowercase letter. Because capital B and lowercase b are going to mean totally different things. All right? Same thing with capital A and whatever we're talking about. Capital letters and lowercase letters are going to be totally different. So you got to be really, really cognizant of that. So we're going to be named by a capital letter. And this capital letter is not only the center, but it's also the name of the circle. Okay, so pick a letter. C. C. So we put a capital C there, and that circle right there would be called C. So we'd say this is, so that's not only the center, but it's also the name of the circle, and we would write it as, or write with the symbol of a circle with a dot in it. So we would say this is circle C. So whatever other letter you might have put in there, we can have that letter put in there. From here then, they start talking about, they introduce some other words. So if I had something from the center of the circle to the outside of the circle, what would I call this segment right here?
Radius.
A radius, right? So we're going to have a radius. And the radius is simply a segment. Do you understand what I mean by when I use the word segment? What's the difference between a segment and a line?
A segment stops.
A segment stops. A line goes on forever, right? So radius is a segment that connects the center to any point on the outside of the circle.
What's the long rate? Like the long one?
We're getting there.
Oh yeah.
Okay? So, what would happen now if in the same radius, if I extended my radius and kept it going and then put an arrow on it? This is a what?
Right.
Yeah. Okay. So from here then we introduce the word ray. And a ray has, what do you call a point at the end of something? Either a segment or a ray. Okay. Has an end point. So if you hear the word end point, it just means it's at the end of whatever you're talking about. Has an end point and extends into infinity. What's that mean? Goes on forever. Has an end point and extends into infinity. In one direction. So a ray, if I connect two rays, I could possibly make a what? If I had opposite rays, I would actually make a what? a line, right? And that those endpoints would be at the same thing, and then we extend in both ways. Okay? So we have arrays. If I would then go through this, oops. And we have, so we're going to have C here, and let's give me another letter. D, somebody said. Okay. So Ray has that's the definition, and it's written with 2 points. But the first point is always my what? Or, yeah, is always the end point. In our case, it's going to be a center because we're talking about a circle. But we can have an array just normally too. So we're going to write it with 2 points. Any 2 points on that array, we can kind of say that, but it definitely has to include our endpoint and then any other letter that's on there. So realistically, we could have this point right here and this point right here, and if I called this one E and if I called this one K, I could have CE, I could have CD, and I could have CK, basically representing the exact same array. Does that make sense? Okay, so we want to write it with 2 points. So in our case, if we eliminate and go back to just the first 2 points that we had, so kind of ignore those, we would say that our array is, in this case, CD, so I'm going to write them. But the first letter is always my center or the endpoint. And then don't forget, you have to put a symbol over top of it. And the symbol of array is just simply kind of like an arrow. Now, if you wanted to put an endpoint there, you can, but you don't necessarily have to. But you got to have that symbol over top of it so you can differentiate between segments, rays, and lines in geometry. Okay? So again, this is kind of a real broad introduction to this stuff. Okay? So, again, if we had a ray that was in the opposite, then we would go in the other way, as Mr. Knight told us earlier, and then we would actually have a line now because 2 rays would form a line. But you don't want to just say any 2 rays, right? Because they'd have to be opposite rays, because we want them to pair up exactly and make a straight line. Okay, so where rays really come up, that we're going to talk about today, is that we're going to use rays to make angles. Right? So in an angle, we could go back and we could do the same thing over here, and we could start at the center and make our rays in 2 different rays. So we start out with CD, and now somewhere, let's make another ray right here, and let's call this one C, what? F. Okay? Okay, so CF is my second ray. So when we do this now, we're going to form an angle. So angles are simply 2 rays that start at the same endpoint. So we can look at it in a circle, or we can just look at it in general. So let's basically try to draw the same one that we had over here. And then put the points that we had, which were D, C, and F. And so if we talk about the same endpoint, my endpoint in my diagram here would be what? For each of my rays. Still my C, which was my center, but we don't call it a center when we're talking about angles. What do we call this part of an angle? Where the rays came from. Any idea? So it would be the center of my circle, But what do we call it if we take it out of a center? This is my, this is really an important word, vertex.
Oh, yeah.
Okay, you ever heard of that word before?
Yes. Particles with vertex.
So the common endpoint, or the same endpoint, is my vertex. Okay. So, everybody good with angle? So how do I name an angle?
Letter. Wait.
Okay, so number one.
Do like the sideways.
First, okay, so that's a good point. Let's write that first. It's represented by the symbol. Now here's where you got to be kind of careful. Just put a little angle symbol, but it often looks like a less than sign, so you got to be really careful if you're kind of talking about inequalities and angles at the same time. All right, so it's represented by this. And then to name an angle, we basically have 3 different ways that I can do this. Okay? Number one way that I can do this is just by the vertex. So what would we call our angle here? Angle C, right? So just by the vertex, we write angle C. The second way that I can name the exact same angle is to use 3 letters. Okay? And so now we're going to, and if you do this one right here where you're going to use 3 letters, the vertex has to be in the middle. So it has to be the middle letter. So what is my angle using 3 letters?
DCF.
DCF. Okay, so angle, don't forget your angle symbol. DCF. Now, can I say FCD? It mean the exact same thing? Absolutely. So, or angle FCD.
Do you have to put a line over it?
No. My symbol now is the angle, because I'm worried about the angle and not the raise. So, good question. All right. So my third way, and I don't know if they really do this in your book, but the third way would be by a number. And like I said, this is more for geometry when you get there, because I don't think they talk about this in your book. Oh, yeah, they do. But they would put a little number here. So besides calling it angle C or one of these, I could also call it angle 12. All right. Now, when would I want to use number 2 instead of number 1?
When there's multiple like rays coming out of the vertex.
Perfect. So if we now extended this and put another ray here and called this one what?
R.
A, somebody said. Okay, so does everybody see in this particular example right here why I cannot call this angle C? Because how many angle C's are there? 2, right? There's actually a couple, more than 2.
3.
Okay? And realistically, if you want to get technical, there's actually 4. Because you could talk about the one that we talked about at the beginning, and then you could talk about this one by itself, and then you could talk about the whole one, right? And then realistically, you could talk about this angle this way too.
Oh yeah.
Now, that's way down the line, because that's probably not until Algebra 2 or Trig. We won't even do that in geometry, but there would actually be that 4th one too. So you see the difference? If you say angle C in this example right here, it's half wrong, because I don't know what angle C you're talking about. Okay? Make sense? So, what would, don't say it out loud, let everybody have a chance. What would I name this angle? Right here. Everybody got an answer? Alexander.
ACD.
ACD.
But with the signal.
What the angle symbol? What would I name the entire angle, meaning here to here? ACF. Now again, Mr. Colbeck's going to be different. So he's going to say FCA, and when you're checking your answers, you're going to say, well, we're both wrong because we don't have, but it's the same thing, right? So it doesn't matter which order you go in, just that C has to be where?
Middle.
In the middle, every single time. Make sense? So, what do we know about angles? Besides that, how are they measured? Okay, what? Yeah, so, measured in degrees. So again, if we're going to be a real stickler about this, you need a degree symbol. Whenever you're talking about what you're talking about. So in our case, if we go back to our original angle DCF is equal to, we would try to figure out what that is. How much? 65. I can maybe live with 65. And then don't forget your degree symbol. Okay? Now, how do I know this for certain? What do I use? I said. So, measured in degrees, but found by using a protractor.
It's not used for farming, Alex. Don't get your head right.
Okay? So everybody know what a protractor is?
It's like a line and bottom. It's like a half circle with like.
Like a half circle,
It's
right?
like a ruler kind of. So a half
Kind of like a
circle.
ruler, yeah.
It measures the angle.
All right,
Wow.
take one out.
It's so good. Great.
Like this one.
It's like after classic,
What?
So, I don't know if you've used one of these before or not. It's no big deal if you haven't. We'll show you how to use it. Alright? So, everybody got theirs? Gotta get mine out. Alright?
Why the line?
So, yeah, some of them have a little stick or an arm on it. Okay? No big deal. That arm will help you out. Alright, so, why do we talk about circles at the beginning? Because if I had two protractors, what would it make? It'd make a circle, right? So basically, notice the numbers around your protractor, right? We start at 0, and it goes all the way around, and it gets to 180. But why does it work in both directions? Because it just depends on how our angles are drawn. Are we drawing them this way, or are we flipping them over and drawing it the other way? So we can measure them both ways. All right? But we're going to use this to actually measure it. Now, you should somewhere have like a dot, or like mine just has an indentation here. Okay? But find that spot. That is at your 0. Notice straight up and down. If I go from that point down at the bottom straight up, how much do I have? 90 degrees, right? So when I'm going to, I want everybody to draw an angle. I don't care. Make it look something like mine so we're all on the same page. So let's do, let's go this way. We'll make it a big one. And what do we want to call
70.
it? No, what do we want to call it? K.
Yes.
Okay? So we have K. So we're going to try to figure out what angle K is. So everybody try to make something that looks like this. It's not going to be exact. That's okay. All right? So we're going to take our protractor, and you're going to put your divot or circle or whatever you have, where? Where do I put this?
The vertex.
On the vertex, right, or my K. So I put that on my K, and then I'm going to line up. So here's something that maybe we didn't talk about. What do I call these parts of the angle? This part of the angle.
Vertices.
You'll hear that this, because the vertex is this, maybe they'll call this the arm of the angle sometimes. Okay, or the side, right? The side of my angle. So if you hear those words, that's just what it's talking about. So I'm going to make sure that my point or divot or whatever is on my vertex. And then one of my arms of my angle has to go across the straight edge of my protractor. Now some of them are a little different. So here with Grace's, I don't know if you can see it, but there's a little black line across. A lot of yours have that little black line. That little black line should go right across on one of my arms. One of them, it doesn't matter. Okay? I'm usually going to put it on the bottom. All right? I can't pick it up. Yeah. See, you can't either. Oh, good job, Grace. All right, so we're going to try to figure this out now. So again, make sure that you understand how to use it. Anybody confused with how to use your protractor? You are? Put your dot on your vertex. Now put this straight side right here on your bottom line. Right here, this bottom line. Yeah, you got to draw an angle first. All right, so basically what we're going to do now is there's two different sides to my protractor, right? So I have numbers that are bigger than 90 degrees, or I have numbers that are less than 90 degrees. Everybody see that on your protractor? Okay. So what's the difference? Well, the difference is how we're going to basically classify the angles. So let's keep your angle there, but then let's talk about classifying angles. So if I'm going to classify angles, I'm going to classify it in three different ways. What are the three possible ways to classify an angle?
Right, obtuse, and then acute.
Perfect. So right, we'll start out with, and what is a right angle? 90 degrees. So that's why we have a protractor, and straight above us is my 90 degrees. So, put 90 degrees, and if you want to draw or try to draw a quick one, we just put this here. Now, how do I know for certain that that's a 90 degree angle? How can I tell everybody in the world that that's a 90 degree angle without me writing the number 90 degrees? You put a little square or a box in that little corner, okay? So, come back. This right here, this is where you got to start accepting things. Meaning, if you looked at that angle right there, and Caleb wants it to be 90 degrees, he draws this right here, and Carson comes in, and Caleb says, that's 90 degrees. Carson says, no, it's not. Who's right? Carson. Because why? Because I have no idea what that is until we come back and put that box in there. Okay? If the box is in there, you cannot argue it. It's a certainty. It is 90 degrees. If that box isn't in there and they say it's 90 degrees, you say false. Okay? That's a true statement from here on out. All right? Number 2 is, what did you say? Is acute. Okay? So what's acute mean? Perfect. So we have acute angles. And these are angles less than 90 degrees. So realistically, I'm going to say my angle is less than 90 degrees, but greater than what? 0. Perfect. And then my last kind were what kind? Obtuse. So now do you see why we have to have numbers going both ways on my protractor? Because we can measure both kinds both ways, right? So number 3 is obtuse. And that means what? Angle greater than 90 degrees. And realistically now, you know, we get to the end. So if you want to argue this a little bit, we could say that there's actually a fourth measure. So the first one was 90 degrees. The second one, depending on how my angle is either less than 90, but whichever way you're looking at it, right? The third one's bigger than 90, so again, either way that you're looking at it. And then the fourth one would be what?
A line.
A line. And the line would be if it's straight across. So realistically, you could say it's the fourth one, but here we just want to say that it's greater than 90 degrees for an obtuse angle. Okay? If it's a line, yes, I believe it will. So yeah, if you want to write that real quick, the fourth way would be a straight line. Now here's where you can probably have an argument sometimes, is with my 90-degree angle, there has to be a box. With a straight line, there's nothing really to show that that line is in true straight. So, you know, this right here, I have no idea if that's 180 degrees. It could, right? But this is one of those things where they don't want you to argue that fact. If they say that this is a line, it's a line. And if it's a line, then it has to be 180 degrees, even though that it's not, could be 179.
Can you
Put a circle, like half a circle on?
You could, but you're not going to see that ever. You're saying like here?
No, like in the middle.
Yeah, where's
you
the
put a
dot?
circle, like the right angle, but in the middle you put a circle, and you get to go like that.
Oh, like this?
Yeah.
Yeah, I suppose, but you never see that. So, measure, come back and measure your angle that we had. And see what you have. Real quick, before the bell rings.
130.
Mine was about 119.
130.
So, put your protractor away and we'll finish tomorrow.
Where's the box?
I got 130 on this.